Welcome all. In this lecture, we will discuss about block diagram representation of systems. So consider the transfer function of a system as TF is equal to y of s by x of s, where y of s is the Laplace of output signal and x of s is the Laplace transform of input signal of the system. Then we can write TF will be obviously, since y of s and x of s are function of s, this transfer function will be a function of s, so it can be represented as g of s, or we can write y of s is equal to g of s into x of s. So we can represent this as a block diagram. Say here we are giving input signal to this block and output signal is y of s. Input is x of s and output is y of s. So this it is related such that y of s is equal to g of s into x of s. So inside the block we are giving the transfer function g of s, the term g of s. So we can represent the system by a block diagram or block, where the block represent the transfer function of the system, and there will be a input to this block and there will be output from this block, and output is related such that input into the value of this block, that is transfer function. So next we can discuss the components of a block diagram. So consider a simple block diagram. So here R of s is the input signal and C of s is the output signal. So as in the previous case, the transfer function is not given in a single block, it is a complex one. Okay, it is having some feedback and a gain. So first, as obvious, the first component is the blocks. So consider these two, these are the blocks in this one. So blocks will be representing a transfer function having a value. It will be having an input and the output will be the input into that value. So that is the blocks. So this is the first component of the block diagram, block. And next is summing point. So consider this is the summing point here. So summing point is used to sum the signals. So say here R of s and this signal are plus this minus. So at this point it will be the result of R of s minus this signal. So we can add, say, this a plus b, y equal to a plus b. So at this point the result, this will be the result of a plus b. So that is represented by this summing point. Or we can do the difference also. Here it is sum difference. So for difference we are notating minus. So a is plus and b is minus, so result will be a minus b. And we can use number of signals to add or difference like that. So a, b, so a and b are adding to this and c is minus, so result will be a plus b minus c. So we can have addition or subtraction of number of signals in a summing point. So this is about summing point. And the last component is takeoff point. So this is the takeoff point. Okay, this takeoff point. So takeoff point is, say here, is used to take the same signal as the input of another blocks. Okay, so say here this same signal is taken as the input of these three blocks. So for that we are using this takeoff point. Okay, so here this one, these same input R of s or same signal. Okay, it can be at any point, output or in between the block, anything. Okay, for making the same signal as input of block or another part, it is we are using takeoff point. So these are the components. Next we can discuss the block diagram algebra. First one, series connection. So this is actually a series connection. Say this is the input signal to the first block and the output of the first block is taken as the input to the second block, and this is the final output. So what we can do to reduce to a single block, so that is the series connection. So here we can say, so we have to find or we have to replace these two blocks by a single block. Okay, so we can say this a of s is the output of g1 of s, let it be the output of g1 of s, so it will be the input of g2 of s. So we can write a of s is equal to, from block 1, this relation. Okay, so this one block. So this is the input and this is the output. So output and input are related such that output is equal to this input into this transfer function g1 of s. So it can be written as a of s is equal to x of s into g1 of s. Similarly, from block 2, we can say that y of s, this output of this block is equal to input of it into this g2 of s. So a of s into g2 of s. Again, we can say that this y of s is equal to a of s into g2 of s. But a of s is x of s into g1 of s. So we can say substitute a of s here. So x of s here. A of s become x of s into g1 of s. Or we can say that y of s by x of s, that is the transfer function of this. Okay, if you are replacing by one block, it will be equal to y of s by x of s. So it will be equal to g1 of s into g2 of s from this equation. Y of s by x of s is, so means we can reduce this into a single block where the value is the product of these two. So if there is a series connection, it can be reduced to a single block by writing it as the product of these two transfer functions. Okay, so that is the series connection. Next one is parallel connection. So in parallel connection, the same signal is multiplied by this block and this block, and it is added. So again we can have so we have to find a single equivalent block for this complex block. So let this signal, at this point the signal is y1 of s, means the output of g1 of s, block g1 of s, and the output of this block g2 of s is, let it be y2 of s signal. Okay, so means at this point the signal is y2 of s, and at this point signal is y1 of s. So from first block we can say that y1 of s is the output of this one. Its input is x of s. So we can write y1 of s equal to x of s into g1 of s. Similarly, for block 2, y2 of s is the output of the block 2, and the input is x of s. So we can write the output, this output is equal to input into this one. So y2 of s into equal to x of s into g2 of s. But we can say that by the summing point, this y of s is actually we are getting the result by adding y1 of s and y2 of s. So y of s is equal to y1 of s plus y2 of s, which is equal to y1 of s is x of s into g1 of s, and y2 of s is x of s into g2 of s. So we can substitute here. So we'll be obtaining x of s into g1 of s plus x of s into g2 of s. So we can take this x of s outside. So x of s into g1 of s plus g2 of s. Or we can write y of s by x of s, that is the transfer function of the whole, as g1 of s plus g2 of s. Means we can convert this into a single block where which is equal to g1 of s plus g2 of s. Means it is a summing. Parallel connection means it is a summing. So if there are any diagram like this, we can reduce into a single block by adding this. Next one is feedback connection. So this is the feedback connection. So actually it should be noted that this x of s is coming from to this point, and here also it is going forward. Okay, and if you are looking here, this connection is a feedback, means this connection is a backward connection. The signal is taken from here and the arrow mark is to this side, so it is a feedback. It should be noted that the arrow mark is in reverse. It is called feedback connection. It's a feedback, means some amount of output is subtracted to this with the input. That is called feedback. Anyhow, we have to reduce this into a single block. So for that, let this signal, at this point the signal is c of s, means x of s minus this this signal, so that is c of s. So let this signal is f of s, means output of h of s. This is also a transfer function. Okay, this is input and this is output. Okay, because arrow mark is in this side. Okay, here for g of s, e of s is the input and output is y of s. Here for h of s, input is y of s and let output be f of s. So we can say that from block 1 we can write the equation as y of s equal to input into g of s, e of s into g of s. Okay, input of this one. Similarly for block 2, input is y of s and output is f of s. So f of s is y of s into h of s. but we can say that from the sum block we can write E of s is equal to x of s, it is plus, and f of s is minus, so x of s minus f of s. Signals are summed or subtracted using summing point. And again we can have f of s or y of s. Y of s is equal to, if you are looking here, x of s minus, so we see we can substitute this E of s in this equation. So we can say that E of s, instead of this E of s we can substitute x of s minus f of s. So we can say that y of s is equal to, instead of E of s it become x of s minus f of s into g of s. Okay, so we'll be obtaining like this, and we can multiply, or we can say f of s, we can substitute f of s. F of s is equal to y of s into h of s, so it will become like this, and by multiplying it will be get x of s into g of s, here y of s g of s into h of s, and we can take this side, so it become y of s, this one, and this term is g of s into h of s is equal to x of s into g of s. And now we can directly write the transfer function of this whole, that is y of s by x of s. Y of s by x of s become y of s by x of s, this g of s divided by 1 plus g of s into h of s. So this is the transfer function, or this is the equivalent transfer function or equivalent block, the value of equivalent block, g of s by 1 plus g of s into h of s, a single block. But again here it is minus, so it is called negative feedback. So negative feedback means it is minus, so this become here plus here. So for positive feedback means this will be positive. Okay, the signal will be the connection will be plus here, so it will be minus here, that is the difference. Okay, so we can use this for positive and negative, so it should be noted that whether it is minus or plus here. If it is minus, it will be 1 plus in the denominator. If it is positive here, it will be 1 minus here. So we can convert this into a single block. Here it is minus, so it will be plus. If it is plus means it will be minus here. So that is the feedback connection and the equivalent single block. Next one is shifting summing point after the block. So in some cases, in order to reduce the block diagram, we have to shift this summing point after a block. So here g of s is here, so we suppose we want to shift this into this side. Okay, like this. Okay, this summing point should be this one. So at that point what we have to multiply with this x of s, that we have to find. Let it be a of s, we can find that. So let this signal is e of s here, the input of g of s or output of r of s plus x of s. So we can from block we can write as this is input and this is output of g of s. So y of s is equal to e of s into g of s. Again e of s is equal to the sum of these two, r of s plus x of s. So we can substitute there. So here become x of s plus r of s into g of s, and we can multiply. So x of s into g of s plus r of s into g of s. Next, from this we can have this signal as f1 of s, the output of g of s, and this signal output of this a of s. This value of a of s we have to find in terms of g. So again here f1 of s is the output of this, so g of s into r of s, r of s into g of s, input into this value, input signal into transfer function of this block. Again f2 of s, it is from this block, x of s is the input and a of s is the transfer function, a of s. So f2 of s is equal to x of s into a of s. So again at the summing point y of s equal to summation of this, so f1 of s plus f2 of s, y of s equal to f1 of s plus f2. So we can substitute this, so become r of s into g of s plus x of s into a of s. So actually we are replacing this by this one, so the output should be same. So we can equate these two output. So this is for this one, and this term y of s is for this one. So we can equate these two. So this become here and this term become here. So we can it is common here, r of s into g of s is common, so it can be cancelled. So when we cancel this, it become x of s g of s equal to x of s into a of s. So again x of s is common, so at last we get a of s equal to g of s. Means here the value is g of s, means we can have this g of s here, or if we are shifting this sum block after a block, we have to multiply the input by g of s. So we have to add a, instead of this one here, there is no gain here, okay, but here we have to add this value g of s if we are transferring this summing block to after this block. So we can easily transfer this into this side. And next, the reverse, means we are moving this summing block before this block. Actually this summing block is here, so if we want to move before the g of s, what we can do again, if we are moving, we have to do a multiplication factor here. So we have to find that, let it be a of s. Then again from this say this output of g of s, let it be e of s, this signal e of s. So we can write e of s equal to r of s into g of s from this one. And again at this summing point, y of s equal to this 2 x of s plus e of s. And we can say this e of s is r of s into g of s, so we can substitute for here. So it become x of s plus r of s into g of s. Let it be the y of s from this figure. So again we can find this from this also. For that, let this input of g of s become, let it be f1 of s, and output of this a of s, that we have to find this value, let it be f2 of s output. Then f1 of s will be equal to r of s plus f2 of s, this two signal by summation. The summing point f1 of this signal is equal to sum of these two, r of s plus f2 of s, and f2 of s is equal to this input into this a of s. And again we can have y of s equal to the output of this, so input into g of s, f1 of s into g of s. Again we can substitute f1, so f1 is r of s plus f2 of s, so r of s plus f2 of s into g of s, and we can substitute for f2 of s, so it become r of s plus x of s into a of s into g of s. Substituting for f2 of s, we equal x of s into a of s. So we can equate these two because output should be same. So x of s plus r of s into g of s here, and this term here. Now we can multiply multiply, so it become r of s g of s, and here x of s a of s into g of s. So what we can do is we can cancel these two common terms, r of s g of s and r of s g of s. So it become x of s equal to x of s a of s g of s. So x of s can be cancelled, or it become a of s equal to 1 by g of s, means the value of a of s is 1 by g of s, or we can convert like this, means we can shift this into this side, but we have to multiply by 1 by g of s. The x of s here we have to multiply by 1 by g of s if we are shifting this into this side, And next is if you are moving the takeoff point. We discussed the movement of summing point. Next is shifting of takeoff point. So this is the, now the shifting point is here before the block. So if you are moving after the block, it will be like this. So here we have to find this value, multiplication factor. So from this figure, x of s is equal to r of s. It is same. Takeoff point, this takeoff point, and y of s equal to input is r of s into g of s. From this figure, r of s is equal to, or y of s is equal to input into g of s. So r of s into g of s, and x of s equal to y of s. This is the input of a of s is y of s into a of s. So we can equate these two. So x of s is again y of s is r of s into g of s, so it becomes r of s, g of s, a of s. So we can equate these two, x of s. So r of s into g of s into a of s equal to r of s, or we get a of s equal to 1 by g of s. So if we are moving this takeoff point after the block, we have to multiply by 1 by g of s, this block value. Next, if what happen if shifting takeoff point is before point is moving to before the block. So this is actually after the block, we have to move to this side. So we have to find what is the multiplication factor. It will be a of s. So here x of s is actually y of s. It is same signal, and y of s is equal to input into g of s, r of s into g of s, or x of s equal to y of s, so r of s into g of s. So again, from here, this figure, y of s is r of s into g of s, and x of s is r of s into a of s. So we can equate these two. So r of s into a of s become r of s into g of s, or a of s will be equal to g of s. So if you are shifting this point to here, we have to multiply by g of s. So these are the algebra. So by using this, we can reduce the block diagrams into a single block. So by this, we can wind up this session. Thank you.